Hello again, everybody, and thank you so much for joining us here today. My name is Paula Basili, and I lead up strategic communications at the Center for Geospatial Solutions, which serves as the home for the Internet of Water Coalition and all of its related efforts. And so we are so excited to be back today, this Monday, with a continuation of our IOW Coalition webinar series. Today, we have a special guest speaker, Matthew Brousil from the Radical Open Science Syndicate Lab at Colorado State University, who will be presenting around the EPA TATTAINS package for some exciting new upgrades to the EPA's TATTAINS package to make the water quality portal easier to access than ever. Now, before we do get started, I'd like to just cover a couple of housekeeping items. You'll notice that we are recording the webinar today, and that's so everybody who wants to revisit the content, who wants to share it with their colleagues and friends will have access to that both on the Internet of Water Coalition's YouTube channel as well as at our website. So if you'd like to refer back to anything, please check back in a day or so, and that content will be made available for you. We'll also be taking questions throughout the webinar in the Q&A function of the chat. So if you do have any questions, feel free to drop them in at any time. We will be saving those questions for the end and addressing them together then, but please submit them through that Q&A button you'll see below. If you do have any technical challenges, meanwhile, do let us know in the chat and we will work through those as quickly and as best as we can. So now I'm going to say, let's head on to the main event. Like I said, please help us welcome Matthew Brousil, who's the lead scientist for Ross Lab at Colorado State University. Matt, we are really excited to have you. Thanks for joining us.
Awesome. Thank you, Paul. It's great to be here. Great to be presenting for all of you. Let's see. Oh, are we good?
I know this is we are seeing the full chat or the notes version of the...
Okay, cool. Thank you. That's what I thought might be the case. This should be good then, right?
Yes, that is perfect. Okay.
Awesome. Great. Yeah, thank you so much. So yeah, my name is Matthew Brousil. I am a lead data scientist at the Ross Syndicate, and we've been working on the EPA TATTAINS package with the EPA folks for a year or two now, I believe. And so today, what I'll be talking about are some of the additions that we've helped to make to that package, both some updates and some new functions, for example, that we've provided. So first, what I'll do is I will go through just a really quick overview of what the EPA TATTAINS package, or I guess it's more of a collection of tools, is and does. And then I'll review some of our contributions to that. Some of these will be both new functionality that we've provided to the package, and some updates to existing functions as well. And then at the end, or kind of like the second half, I'll walk through a little example coding vignette that hopefully will help you folks kind of visualize, understand what some of this functionality does, and give it a test at home, whether that's now or after the webinar. So first off, what is EPA TATTAINS? TATTAINS is the tools for automated data analysis. And so what this is an open source series of tools that are built off of tools in the R programming language. That's both code for those of you who are programmers or R programmers. There's also a Shiny app component, which is essentially a web-based app built off of the R language. For those of you who maybe would want to interact with water quality data through the water quality portal that doesn't require programming language knowledge as a sort of startup cost. So the EPA TATTAINS package is designed to help both access and process data from the water quality portal. And as I'm sure many of you are aware, the water quality portal is a resource with hundreds of millions of observations of various water quality data. And so the EPA TATTAINS tool package is designed to take you from finding and filtering data sets that are available through the water quality portal, then kind of taking that data that's been filtered, doing some analyses, and going on to helping you even do some mapping, some analysis of those data as needed. And hopefully to make that process a little bit more straightforward or user-friendly for you. And so this is a series of tools that are used by states, tribes, federal partners, researchers such as us at the Ross Syndicate, and even more. And I'm sure that we have people from all of those different examples here today, and I hope that you can all make use of EPATADA. So I don't want to spend too much time delving into EPATADA. I'm not one of the architects of it, so I'm not best positioned to explain the whole universe of what it does to you. What I would suggest, though, is if you're interested in taking a deeper look at this, to look at the documentation at the EPA's GitHub. There's both a documentation website and also the main sort of like GitHub page where the development takes place. And so that's all public facing. Can take a look at it. And I've included a little screenshot here of a graphic that they recently posted that I think is fantastic and does a great job of kind of displaying and explaining what it is that TADA does and how you can make use of it. And if you're specifically interested in some of the things that the Ross Syndicate has kind of wrapped and published with them with EPA so far, I have a link here to a specific pull request or like mini data or mini code release rather that you can take a look at, and it provides some information on what we've been doing. So the first function that I want to talk about is the TADA data retrieval function. This was a pre-existing function within the R code package EPA TADA. And essentially what it does is to act as an interface between the sort of data retrieval world, which in R includes the data retrieval package, the EPA TADA package, and then the water quality portal itself. So TADA data retrieval kind of lets you write and submit queries in a streamlined fashion if you are an R user. And so one of the nice things about this function is that it generates EPA-TADA compatible data frames from water quality portal data. And when I say that these data frames are EPA-TADA compatible, what I'm referring to is the opportunity when you use the data retrieval function to auto clean that data and then for it to also be kind of restructured for ease of use. So if you have used or if you do use this function in the future, you'll note that these data sets that come back from the water quality portal will be sort of TADA-ified, if you will, and it'll make it easier for you to use the data and then also enable things like mapping and spatial use of those data sets as well. And so the Ross Syndicate, when we came in, one of the things that we were asked to do was to add some functionality for spatial and tribal uses of the water quality portal data sets. And so the first thing that I would highlight that we've added to the data retrieval function is this argument called AOISF. And what that allows you to do is to actually query the water quality portal using a spatial object. Not directly, it's kind of a like behind the scenes process that I'll explain a little bit more in a moment. But it provides that functionality where that didn't exist before. Second, there was also a need for a more straightforward way to query tribal data. And so we've added two arguments to this function, one of which is tribal area type. It refers to one of 6 different map layers that can be used to indicate different tribal area types. More on that in a few slides. And then a tribe name parcel argument as well, which lets you hone in on the specific boundary that you're looking for. And so I'll demonstrate that in a minute here, but those are kind of the 2 biggest contributions as I see them to our work with data retrieval here. So I had mentioned a minute ago that the water quality portal doesn't allow users to directly query from a spatial object. But if you've pulled data from it before, I think it's very likely that you've wanted or, whether or not you realize it might have benefited from this functionality. So what we do in using the spatial objects in R for this is the user first gives us or gives the function rather a spatial object. This is an SF object in R. And because the water quality portal will accept bounding boxes, what we do is to grab the bounding box from the spatial object that the user provides. and then provide those bounding box coordinates to the water quality portal. And then in the third map here, you can see that it provides us in return all of the different water quality portal monitoring locations that are returned from that bounding box. And if you have provided the original spatial object in the first panel here, you'll see that there's a fair number of points that are outside of that. So the last step when we're enabling users to query with spatial objects is for us to then clip what's returned from the water quality portal to the actual specific location of interest within that spatial object. So this is kind of just an idea of what's going on behind the scenes with TADA data retrieval now when you use a spatial object. The reason I present this is because I think that for those of you who are familiar with the water quality portal already, you might be wondering like, how is this magic happening? And well, here it is. Here's what we are doing kind of on the back end. And then one last thing that we've added with the data retrieval function is we've actually merged it with a previously existing function called TADA Big Data Retrieval. And because of the sort of size limitations for queries with the water quality portal, the big data retrieval function was necessary to prevent essentially overwhelming the database when queries are being made, which as someone speaking from experience, a couple of years ago when I first started working with the water quality portal, I was very aware that this was incredibly easy to accidentally do, like if you just don't have a sense for the size of the query that you're providing. And then also, incredibly easy to do. And it was something that kind of terrified me. So knowing that big data retrieval is an option, what we wanted to do is fold that into TADA regular or TADA data retrieval. And so what this does now is when you provide a query to TADA data retrieval, the big data retrieval process has been updated a little bit, and it happens now automatically detecting whether or not you've queried a large data set. And so for reference, things by default that will kick in that big data retrieval process are queries, I believe, over 250,000 records and/or with site counts greater than 300. So if you're asking for more than 300 sites worth of data at a time, that's where this process will kick in kind of in the background, and it'll let you know also. Along with that, we added a progress bar, a user prompt to make sure that you want to download large data sets before you actually commit to it, and then some error handling and sort of message handling, just kind of, again, in the background. So I had mentioned a few minutes ago that we had added the option to query by those two text fields for tribal data. And while we wanted to make sure to add that, we needed to also ensure that users kind of knew how to navigate that data or the information that they were trying to provide. And so what TADA tribal options does is it basically allows you to access information for the different spatial tribal related layers that are available for querying with. So I've included a screenshot here of the tribal map server data. And essentially what this is to highlight is that for the tribal area type option, there are 6 different strings or options, I guess, that you can use. So one is Alaska Native allotments, Alaska Native villages, off-reservation trust lands, the Oklahoma tribal statistical areas, Virginia federally recognized tribes, and then American Indian reservations. So when you're using the TADA tribal options function, you can provide one of those 6 options. Technically 4, because 2 don't work. I'll point those out in a second here. But then you'll be provided with all of the data that kind of meets those categories that's available to you. And so that note is the Alaska Native villages and Virginia federally recognized tribes don't currently return data from the water quality portal. That is because of the way that they're stored. They're stored as points as opposed to like polygons that have like an area inside of them. And so because they're points, there's just like not anything available to intersect with them. And to display this, just quickly visualize, you can see the way that these 4 different layers are distributed and the sort of size of them relative to what you might be wanting to query. Okay, the next function that we added is the tada make spatial function. And so this is new, as I mentioned, and it takes the output of a water quality portal query in a data frame format and converts it into a geospatial SF object. And so there's a variety of reasons why you might want to do this. And if you've done this before, where you've been kind of like searching through like, okay, do I have the right columns for this? Do I need to use the SF package? Like, what am I doing? This kind of simplifies this for you. So we included it, 1, for general use, for example, with mapping. And then also 2, in order to be able to support ATTAINS functions where you can join assessment units to water quality portal data. And so this tada make spatial function requires a certain like input data set format. And the little screenshot here has the 3 columns that are necessary in order for that to work. So the first is your monitoring location identifier. Second is latitude, and then the third is longitude. So if you have those 3 in the data frame that you provide to this function, you'll be able to get a spatial data set out of it when you try to run it. Oh yeah, and so this is the output. Essentially, what would be visualized here is all of the water quality portal lat and long information that went into that original function. Okay, so I kind of previewed today ATTAINS a little bit. So we've also added this function, and Katie Willey is the person in our lab who created this and the other ATTAINS stuff. So she's kind of like our team pro for the ATTAINS things. But what this does is to allow you to link the water quality portal data that you're getting out with tada data retrieval to the ATTAINS assessment units directly. And this also includes now an option to return the SF, or to return rather an SF spatial object, which maybe is helpful for you, but also necessary on our side of things in order to plot that as well with another function that we've built. And Katie also added this option to fill in catchment information from the National Hydrology dataset if there's not an intersecting ATTAINS catchment. And so to do that, you would use the fill catchments equals true argument in this function. And you can either use the NHD high res or NHD plus version 2 for this. Okay, so lastly, I had mentioned in the previous slide, I think, that you have the option of getting a list of all of those SF objects from the tada get ATTAINS function. And the purpose that we have for that here is to actually use that for tada view ATTAINS, which allows you to map the ATTAINS data and the water quality portal observations. So those 2 functions kind of go hand in hand. So yeah, the map that it creates will display the locations alongside those ATTAINS features, as well as any NHD catchments that are returned with that argument that I mentioned. And so what that might look like in one example is here. I believe that in the bottom left-hand corner here is an example of one of the polygons without an ATTAINS feature, but that was returned with the fill catchments equals true. Okay, so hopefully that all makes sense. And what I'd like to do now is to just dive into a little function demo here and talk through an example of some of this functionality. So I'm going to switch over to R. And I do want to just give you folks a heads up that I'm not going to be doing this with the assumption that you're following along on your own, just because there's kind of been enough quirks with the water quality portal and the Tigris package lately, where I'm not sure that people are going to be able to have the sort of like on-the-go error-free experience that I would like you to have. So I'll just be kind of demoing this and then and talking through it. Okay, so what you should be able to see here, and Paul, let me know if that's not the case. There should just be an R script here with a couple of packages that I'm going to be loading, and I will walk through just a couple of quick examples with some of those functions that I've mentioned. So here I have the EPATADA package, tidyverse, which I'll be using to manipulate the data, Tigris, which we will see if it wants to work. I've had a couple interesting interactions with the package today, and then SF for mapping and map view also to visualize map data or spatial data. And what we've got here are just some kind of standard messages about some little updates I should do and haven't done yet, but we don't need to worry about that. Okay, so as I mentioned, we have developed two ways to sort of improve or provide more options for the sort of querying process with the water quality portal. One is using spatial data with the AOI SF argument into data retrieval, and then two is using text inputs to select tribal land more directly. And so I'll walk through an example using both of those here, querying data from the water quality portal for arsenic measurements within the Navajo Nation. And so first, what I'll be doing is, I'll be showing how to use SF objects with TDA data retrieval. And so let's go ahead and find out if Tigris is working for us. I'm going to use the native areas function from Tigris. And running this will just provide a list of, or rather a data frame of all of the available, essentially spatial boundaries. But I want to filter that to just a specific ID for the Navajo Nation. And so what I want to use here, and okay, so I'm going to create an object called Navajo shape here, and we'll see if this runs. I do have a backup if it doesn't, but it looks like we'll have some success here. Okay, so that looks good. We'll just double check. Okay, and that's what I would want to see. For those of you who are unfamiliar, this is the sort of structure of a SF object or a simple feature object in R. It's like a data frame that acts as a spatial object, essentially. So I'm going to clear this just so we don't get too distracted. And I'm creating a new object now called tribal query shape. And so I'll be using TDA data retrieval for this. And so here is that our mythical goal of being able to use a spatial object to query the water quality portal. So what we're going to do is say we want AOI SF to be our Navajo shape object. I'm going to use the characteristic name arsenic. For a start date, I'm going to go for a year's worth of data here. It should go pretty quickly. So 2019, January 1st. And then for an end date, we'll go for December 31st. And yeah, actually, so here's an opportunity for us to see one of, or a couple of the actual smaller pieces of functionality that we've added. So first off, for those of you who use data retrieval before March of this year, this statement, I believe that's new, but with our updates. So just kind of like, hey, heads up, we're checking for data. We'll let you know when we're done. But one thing that the TDA team asked us to do was to add a note, just giving an indication of how much data is available before it's downloaded. In this instance, there's only 216 records, so we don't really need to worry. I can trust me that my computer can handle a lot more than that, for better or for worse. But Microsoft Excel, for a lot of people who are doing management work with this data, that could be a limiting factor. So we wanted to just let people know, like, hey, Excel usually kind of stops working or visualizing rather around 1 million data points or more. So just so that you know, you're going to get 216. That's how it compares. Do you want to continue? And so in this instance, yes, I want to continue, and it'll go ahead with that. And that downloaded really nice and quick. In the future, if I didn't want to go through that process, I could just say ask equals false, and it will not ask me before downloading. It'll just go ahead and do it. Okay. So let's just take a look at this. We'll look at the dimensions of this data set. So we see it's got 216 rows and 150 columns. So that's a thing that's just important to keep in mind, is that the water quality portal contains so much data that even 200 rows of data, you're still getting 150 columns after, like, excuse me, the TADA auto cleaning process, that you need to just be mindful of what your computer can handle and kind of keep that in mind as you go along. So one of the things that we had to kind of think through when it comes to including the ability to use a spatial object is how that interacts with other pieces of data that people might want to be using to query the water quality portal. So I'll show you what I mean. I'm just going to copy this query that I used up here. And let's say that, you know, maybe I'm a new user. I haven't used this AOISF argument before, and I might have accidentally also included a state code as part of that. So maybe I wanted New Mexico. And what we needed to do when we were thinking about this is to kind of think through, like, what's the hierarchy of, if someone is querying with a shapefile, but they also include other geographic information, how does our need to be sort of interpreting that? And so what we landed on is basically, if you provide an SF object to data retrieval like this, and also something like a state code or a county code, data retrieval is going to ignore the state of the county code and only work with the shapefile. Just because otherwise it's kind of a rabbit hole of, like, well, should we get the state? Should we get the county? Should we get everything? Like, you can probably see how that would get out of hand quickly. So this will run, but it will give you a warning at the end just saying that location information has been provided in addition to an SF object, and that we're only using the SF object for the query. So this is more of just like a heads up and an FYI than anything else. Okay. So the next thing I want to show is using tribal text inputs with TADA data retrieval. So now I want to do basically the equivalent query as I did above, but using those two fields related to the tribal spatial data that I mentioned in the presentation. So let's see, what I'll do is we'll copy this and just change a couple things. So we'll change that. Oh no, let's do this. Change it to string. And instead of the AOISF, we're going to want to use tribal area type and tribal name parcel. But at the moment, I don't know that information. So this is where TADA tribal options comes into use. And so there's two arguments to this function. The first is tribal area type, and the second is return SF. And we're going to leave this as false. We don't need it to return a spatial object. We just basically want to get, like, text out of it at this point. And so I have prepared in advance, and I know that the one layer out of those 4 functioning layers that I mentioned in the presentation that I want to be checking right now is American Indian reservations. in order to get the Navajo land boundary. And so if I run this, what I'll get is, should be a data frame. We'll see here. Yeah, so it might not look like a data frame right now. There's a lot of sort of like very long strings of text involved here. But having all that information at your fingertips inside of R as opposed to like on a website, I think is very helpful for this step of the process. So what I know personally I want to do is I want to be looking at the, let's see here, the tribe name column. So I'm going to pull that out. Let's just make sure I got that right. Because ultimately what I want is I want to make sure I have like the spelling, capitalization, punctuation of this correct so I don't get an unintended error. Okay, so I've got all these names, and I know that in this instance, I'm specifically looking for Navajo lands. So I'm going to say that the pattern I want to check for in all of this is Navajo. I'm going to ignore capitalization here because I know that there's some like leading capitalization that I want to get around. And I want this to just return the value to me, like the actual text string. So clear this out. And then what this chunk of code essentially does is checks American Indian reservations, that layer for a tribe name that includes Navajo. And so what I get is Navajo Nation, Arizona, New Mexico, and Utah. And like me being naive to some of these types of information, maybe I didn't know there was an ampersand in there or 3 commas or something like that. This function allows you to kind of see what those values are to make it easier to use them into data retrieval. So now I can go and I'll just drop this into area type, and I will drop this into tribe name parcel. Ah, there we go. I was wondering why that didn't autofill earlier, and now I know. Okay, so we've got the data. Let's check our dimensions again, just make sure it looks comparable. Okay, I think that's good. And just to kind of like complete the magic trick here, let's confirm that the 2 data sets that we've queried are all equivalent to each other. So we will take tribal query shape and tribal query string and just ask R if those are equal, and they are. So the point of this was just to show that you can get the same information whether you're using a shapefile or whether you're using some of the other information options like the tribal options or state, county, whatever. The one thing I will say is just like a caution is be aware that sometimes your shapefile or your spatial object boundaries might not be like exactly what you're expecting. So if you get if you use 2 different sources of shape files, you might get 2 different data sets out of the water quality portal if those shape files don't have the exact same boundaries. So just bear that in mind, but I'm sure you folks are all very well aware of how those boundaries tend to work. Okay, I only have, I think, 2 more short examples here to demonstrate. So we've probably got uh, 5 or so minutes left with this portion of the presentation. So next, what we might want to do is to visualize the data set that we've gotten out of the water quality portal. And so this is where another one of our new functions, ATTAINS make spatial shines. So we can use this function to take the data that we've gotten returned from the water quality portal and put it into a spatial format and to then plot it. And I'm also going to add a little bit of like spatial variability to the latitudes and longitudes because there's multiple responses for like an individual lat long coordinate. And so I want to just like spread them out on the map. So the way that that will work out, I'm going to create a new object called query spatial. And we'll use ATTAINS make spatial. And all we have to do here is, let's see, we'll use tribal query string. Cool. And so now it's taken what was previously just a TDA formatted data frame, and it's created a spatial object from that for us. We can confirm that by looking at it and seeing that this last column here is geometry with the lats and longs. And what I forgot to do is add that spatial variability. So I'm going to run that again, but I'm going to add st jitter, which adds what's called jittering, basically just like random tiny bits of changes in the X and Y coordinates so that points don't overlap so much. So the SF package does this, and I've added it. And now what I can do is go ahead and plot that with the map view package. So we've got that, the Navajo shape that we used earlier on, and I'm going to say, I don't want a legend for this. We don't need it. And then we'll add another layer to actually add the data set that we've made spatial. So we'll add query spatial. And we want to add this layer. So TDA result measure value is the TDA formatted result column from the water quality portal. So we'll basically be coloring points by this. Okay. And you'll see what I mean here in a second. So what we've got now, our top layer is that Navajo shapefile. There is an interactive map underneath it. And we've got the coloring based on those arsenic measurements. And so you can see there's like that spatial jittering that I did here is what's creating some of these like points clustered close together, but not exactly on top of each other. And just to reiterate, this is not, this function in itself, map view, is from the map view package, not from TDA. Okay. And the last thing that I want to do is to just show how we can link the water quality portal data set that we've retrieved to the ATTAINS assessment areas. And so to do that, we will use TDA get ATTAINS. And let's call this query with ATTAINS. And so what I'll do, we've got, I think that this will work with a regular data frame as well as a spatial data frame. I might be wrong about that, but we will use query spatial as our input here for TDA get ATTAINS. And we're going to say that, yes, yeah, we want to have it return an SF list for us. So if you use TDA get ATTAINS with return SF is false, it'll just return you a data frame with the ATTAINS assessment units and some additional columns added onto that. If you include return SF equals true, it provides the output as a list with spatial objects attached to it so that you can create a map or a, yeah, like a plot from that. And I'll show you that in one moment here. So, okay. We also get a little notice about the amount of time it might take. This should only take, I think, 30 seconds or so. And while that's running, I am going to go ahead here and just start coding up the next step. So because we used return SF as true, what we can do then is TDA view ATTAINS. And the output of this query with ATTAINS can then get fed into TDA view ATTAINS. And that will create our map. And so I think one thing that can additionally add some time to this query process here is to, if you include, what was it, the the fill catchments option. At least earlier today, it seemed like it was taking a little longer. So just a heads up, again, this is a 30 seconds or a minute, but keep that in mind depending on the data set. So what we've got now is, well, actually, let's look at this. We've got a few things here as part of this list. So we have TATTAINS with ATTAINS. That's a data frame with the ATTAINS columns added in. And then you've got the spatial objects, the catchments, the points, the lines, and the ATTAINS polygons. And so what we're able to do with that is use TATTAINS view ATTAINS, and it will, and like every time I use this, really impressed at the speed of it. It will create an interactive map, like the one that I had in the presentation. And you can see that the black dots are the water quality observations, and then there are the sort of polygons and all of that associated with the different ATTAINS catchment information for assessment units. Okay. Well, that's all I've got planned in terms of my presentation. So I am happy to answer any questions that folks might have or any clarifications. Yeah, thanks for hanging in with me. And hopefully if you were following along, things worked for you.
Awesome. Thank you so much, Matthew. It's great to see how y'all have made that data a lot easier to use. So a reminder to everyone, if you do have questions, please drop them in the Q&A. I'm going to get things kicked off for us today. And Matthew, I'm curious, this was really great, but obviously a long time in the works. And how did that relationship between EPA and the Ross Syndicate come about? And I'm curious if you could speak a little bit more to that and what you've learned from working together.
Yeah, absolutely. So yeah, we through the Internet of Water had been working to try, and when I say we, I mean the Ross Syndicate. We had been working to try to find ways to put some of this information together and improve like access options for people with the water quality portal, with things like ATTAINS, and through the process of me and my colleague Katie Willie that I mentioned, kind of looking at what was already out there to make sure we weren't going to like reinvent the wheel. And in the process, I did do a little bit of reinventing of the wheel on accident. We kind of learned like, oh, the EPA is doing some stuff that is very close to like what we want to be doing, and we should probably try to partner with them. And so that partnership came about as a result of that conversation and kind of figuring out the most efficient way for kind of funding to be used with a public-private partnership like that. And I think that one of the things that our group has learned, well, a couple of the things that we've learned as a result of that process are, one, what it means to need to be working on a public-facing like software or data processing package in the way that like the EPA's software or our packages are being worked on, right? You need to think about like a variety of different use cases, a variety of different stakeholders. But then also part of what we've been doing is explicitly like helping to maintain the package and add new small features to it or quality of life improvements. And I think that one thing that tends to get overlooked that we've encountered is just like in funding for these types of things, a lot of the thought process goes into like the upfront cost of building a new tool as opposed to the long-term need to maintain it and kind of what costs go into that. So I think that that's been pretty eye-opening for us.
Very cool. And it's interesting. You're right. There's almost that idea of public tools and user-centered design really do go hand in hand. And
Yeah.
now you mentioned the idea of long-term sustainability of work like this, right? And that definitely being a challenge. So can you say anything around how you're thinking about the long-term maintenance of this and what's kind of needed to keep the work going?
Yeah, definitely. In terms of long-term maintenance, like the Raw Syndicate, we're still wrapping up a couple of our kind of like I think it's mostly around the ATTAINS stuff. Oh boy. I think that that's what we're still wrapping up some work on, like not 100% of it is completed. So we're still doing maintenance. But after that, I think like we'll be in the position of like, we would love to keep working on something like this. And I'm sure the EPA would love additional like external funding and external just like support for more development and maintenance of this long term. So from our perspective, that's kind of where like additional kind of private side funding is needed and could come in the future to kind of, help support a tool that like there's, I think, over 420 million records in this database, and
Wow.
time isn't going to stop. So if we can get more funding into it or more long-term support, I think that's a fantastic option in the future.
Yeah. And so you mentioned attains. We do have a question in the chat from an anonymous attendee who just asked if you could clarify what the TADA get attains do. What does TADA
Yes.
get attains do? And could you show
Yes.
the data frame you got when you actually ran that?
Yes. Yeah, absolutely. One second. Let me go back into sharing here.
Yeah. And while you do that, thanks again for everyone dropping in your questions in the chat. We'll get to them all.
Yes, thank you in advance. And I had mentioned that we are still wrapping up a few edits here and there, so we would love feedback on anything that can be improved or anything that we could help make more user friendly. So yeah, the TADA, oops, nope. As soon as the questions come in, that's when everything goes off script here. So with TADA get attains, let's actually look at the help documentation here. So what it does is to take the data set that we got out earlier, which let's see. We got this data set, which like, because there's 150 columns, like only displays so well, but we've got the water quality portal data set, and we want to add the additional information in about what attains assessment units are associated with each individual water quality portal like data point. And so when we go ahead and we get the actual query with the attains data, what I can do here is, so it brings us, because I said return SF is true, it, in this instance, get attains provided us with like a list of multiple items. The first one of those is the data frame with the extra attains columns added onto it. And rather than like trying to show you that entire data frame, what I think we can do here is take a look at the names of some of those columns, and you'll be able to get a sense for what's being added on. So up at the top of this data set, we've got your kind of standard water quality portal stuff, your activity type, media name. This is where we start to see like the TADA cleaning happening and taking place, these TADA columns. And then at the bottom, the last, I think at 30 columns or so, you get the attains information being tacked on. And attains isn't my strong area, but my understanding is that each assessment unit that is associated with a water quality portal observation, I believe, adds a new row to the data set. So your end data set, after using TADA get attains, might be a little bit bigger if there's multiple units associated with individual records. Does that answer the question?
I think so. You can let us know in the Q&A, drop us a line
Yeah.
for another follow-up. I have two more kind of more technical follow-ups too, so we'll just continue on that vein. But one is, what geodetic datum is being used? Annette Nijinsky asked that one.
Yeah, and so I think that that's probably for make spatial, I believe. Okay, yeah, so there is an option to provide your CRS for that. So we've used WGS 84 here, I believe, 4326 for the CRS. So if you want to change that, you can. I think, for those of us who have used Water Quality Portal, like there is a process of figuring out which datum is being used in the data set. And so I'm not as familiar with how TADA handles that after downloading, if it does. So a little bit of like your mileage may vary there, but the short answer is CRS 4326 for make spatial, and you can change that default if you want to.
Okay, gotcha. Thank you. And Jason Jones also similarly asks, where would you go to get the GEOID equals 2430?
Yeah, that's a fantastic question. So let's see. This was a few months ago that I was kind of coding up this example while I was working through this. And I think that where I got that, oh, yeah. So, for example, in this instance, this is referring to a field in the Tigris native areas data set. And so I think what I can do here, take a quick second and see if Tigris will cooperate. That is a specific column in that data set. And for me, it took a little bit of back and forth of like, okay, it looks like this boundary in the Tigris data set is corresponding to this specific tribal land boundary, and essentially just making sure that the points matched up. But if you open up this data set, you can see the GeoID is the third column here. And for me, it was a process of like doing that string filtering for the Navajo the land boundary essentially, and finding things that matched up. So that's where that specifically comes from here.
Okay, helpful. And so let's talk a little bit about kind of where this data comes from, and especially around the sourcing for the tribal lands data specifically. Faith Stern-Leib is wondering where that data comes from. Are you partnering with tribes to see how they may be using that data and are verifying that data? And I guess more broadly, right, it's exciting. These updates are live. People can start using them as they're going out in the real world. What kind of use cases are you all interested in? How should folks get in touch with your team for feedback?
Yeah. So in terms of how to get in touch with us, I think that Anika is probably the best person to kind of like route questions to the right person on our team. And I don't know Anika's email off the top of my head, but I'm sure Anika does. But we are, so really quick. Oh, looks like Anika's name is her email's in chat. Awesome, thank you. I think the first part of that question was about the source of tribal data. Was that right?
Yes, that's right.
Yes. Okay. So I believe the EPA has is it the tribal map server? Just double check this. Yeah, so if you Google EPA tribal map server, there is a website that contains information about those tribal land allotments and the information around like the layers that I was referencing. Not working for the EPA, like I don't know exactly kind of like what that relationship is there. In terms of the data that is in the water quality portal itself, the data are provided by basically people who are collecting the water quality data like out in the field. And so there are a lot of external partners, like third-party partners that do that. Some are tribes, some are other folks. I can't really speak to like where all that is coming from, but for my side of things, like we're not coordinating with people on like getting their data in. It's more about like providing tools to access the water quality portal and make use of its resources. Does that make sense?
Yeah, definitely. And along that question, kind of around the EPATADA, obviously, you're an expert in it, right? Not necessarily. But maybe others are just new to it. And so I'm wondering, how would someone who's maybe more of a beginner start to understand, the real power of that? Is there like a YouTube channel where there are demos for the package or others? Like, what are some good resources to think of?
Yeah, so I think back in my PowerPoint, I had a link that I had just shared on screen of it's like EPA. Ooh, I might be able to pull it up here. Well, there's an EPA GitHub page that hosts their kind of like documentation website, and I think that that is the ideal starting point that I am aware of. I'm not sure if there's a YouTube channel or like video resources. I can't necessarily speak to that, but there are introductory vignettes walking through specific examples of a lot of, if not all of this functionality on their website, their documentation page. And so whenever that our team has built new functionality, we've included a little vignette explanation or like example of that. So anything I've showed here is also in some form or another demonstrated in those vignettes as well. And I believe looking at it today, thanks Anika, that link is perfect. When I was looking at this today, there were some web pages dedicated specifically to like for folks who might be new to R, for example. So yeah.
Sure, fantastic. Sounds like a good starting resource. Well, Matthew, thank you so much for joining us. Is there any last, that's it for our kind of submitted questions. Any last thoughts or things we should know about this or just the work of the Ross Syndicate that you want to leave us off with?
Oh man. Follow us. No, we've got a website, and I think probably Anika can drop that in the chat. I think it's rosssyndicate.com maybe. But in terms of things coming up with EPATADA, there's regular updates like basically weekly or monthly. So if you follow the EPA's GitHub, or if you're able to follow that specific repository with that code, you'll see those updates as they come out. They have a web page about it. And I think one of the great ways to demo some of this, the functionality, if you kind of just want to dive in, is there is a web Shiny app that you can use that kind of takes what's going on in the code and makes it into like a point and click format. So you don't need to be like a hardcore R programmer to actually use some of the tools that are being developed. So I think that's a couple of good ways to kind of keep up with things.
Well, thank you so much.
Yeah.
Thanks for joining us today. That was an awesome presentation. And thank you to everybody who dialed in this Monday afternoon to join us as well, whether you've been to every IRW webinar to date or are joining us for the first time. We really appreciate you taking the time to meet with us and see all of the awesome stuff happening out in the world of open water data. So again, Matthew, thank you so much.
Yeah. Thank you all.
All right. Take care, everybody.